Hello, everybody, and welcome to our water conservation webinar. My name is Juan Marino, and I'm a graduate research assistant with the pollution prevention team here at West Virginia University. I'm very excited to be here and deliver this presentation to talk about a topic that's not only relevant to pollution prevention, but also increasingly urgent water conservation. So over the next 50 minutes or so, I'm going to dive into some practical strategies and real world examples, best practices that can help us reduce water conservation, water consumption, where it's through smart technology, recycling, reusing water, water audits, or system upgrades. And we'll also look at how to measure and track progress so we can see real impact over time. So thank you again for joining the webinar. Let's get started. So here's a quick overview of what we'll be covering in today's session. So I'll start with why water conservation matters, not just globally, but also in our local and industrial context. Then I'll move into an overview of industrial water use, just to set the stage for what's happening in the real world operations and where's the biggest opportunities for savings in the context of water use. Then the core of today's presentation is in the key strategies. So I'll walk you through 5 different approaches that industries can adopt to conserve water. After that, I'll talk about how to measure and track the water consumption and the water savings, because you can improve what you don't measure. Then I'll wrap it up with some technical content with a few additional best practices that can be applied across different sectors, followed by a look at some tools of technologies and resources that can support implementation. So let's get started. So let's start with the big picture. Why does water conservation even matter? Well, on average, each person in the US uses about 120 gallons of water every day. That is a lot. That's a lot of water. And it's more than people realize. So if you look at this graphic on the left side, you will notice that the outer water use alone accounts for 65 gallons. That's more than all indoor uses combined. So that includes things like irrigating lawns, filling pools, or even unnoticed leaks in sprinkler systems. So indoors, the biggest water consumers are toilets, showers, and faucets, followed by things like household cleaning, for example, and the same for the industry. What this tells us is that there's a huge opportunity to make a difference just by improving a few daily habits or upgrading the way we manage water, especially outside. So even simple changes I will talk about later can save thousands of gallons per year. And when you scale that up across different businesses and industries, the impact is really big. So now let's zoom out a little bit and look at the global picture. This map here, it shows the number of months in a year that different regions experience severe water scarcity. So you will notice that areas in red and dark orange face critical shortages for most of the year. Places in like North Africa, the Middle East, and part of the US, and even South America and South and Central Asia are especially vulnerable. So this drives home to urgent realities. First, that fresh water is a limited resource. Less than 1% of the Earth's water is usable for drinking, farming, or industry. And second, global demand is only increasing due to things like population growth, industrial expansion, and the efforts of sorry, and the efforts and the effects of climate change. So without taking action, these shortages will only get worse. That's why we need to both make individual and business changes in our systems to help conserve water and protect our future access to it. So now let's look at how critical water conservation really is. So first, global water demand is projected to increase by 55% by 2050, especially in manufacturing, energy production, and domestic use. So if we keep consuming at the rate that we're consuming, we simply won't be able to meet future needs. Second, only 2.5% of Earth's water is fresh water. So most of it is locked in glaciers or deep underground. So what we actually have access to, lakes, rivers, shallow groundwater, is a very, very small slice of that big pie. And finally, industrial processes waste between 20% and 50% of the water they use. That is huge. It's why conservation strategies in industry can have a big impact. Today, we're going to look at how businesses, industries, and individuals can reduce water waste through smarter systems, new technologies, and better practices. So now let's focus on industrial water conservation. We'll look at how water is used in the industries, the main challenges, and where the biggest opportunities of savings are. This will give us a foundation before we dive into specific strategies. So what is industrial conservation? So at its core, it's about reducing the amount of fresh water used in industrial operations, whether that's for cooling systems, for cleaning, or production processes. But it also includes improving water efficiency, not just through equipment upgrades, but also through smarter processes and behavioral changes. A big part of this is also about reusing water and recycling water whenever possible, which can drastically reduce how much new water a facility needs. And finally, water conservation is about preventing waste and pollution, because reducing discharge or treating it before release is just as important as saving the water in the first place. Now, you might ask yourself, where is water used in the industry? Well, in this slide, we can see that water is used in different areas. These include cooling towers, boilers, steam systems, which are especially common in manufacturing and power generation industries. But then you also have cleaning and sanitation, landscaping. Cleaning and sanitation is huge in food processing industries, pharmaceuticals, and healthcare. And then landscaping, which some large facilities with green spaces or cooling loads affected by outdoor conditions. So by identifying where water is used in the industry, we can start to pinpoint where the biggest savings opportunities might be. Now let's zoom in on the industry's role in the bigger water picture. So globally, the industry accounts for around 20% of global freshwater withdrawals. While that might sound smaller compared to how much water is used in agricultural industry, industrial water use is concentrated and often requires high quality water, especially manufacturing, chemical processing, and food production. So that makes this important, is that these processes not only consume water, but they often generate large volumes of wastewater that need to be treated. Or what are the good news? The good news is that many companies are already finding value in proactive water management, whether it's through their technology implementation, technology upgrades, smarter monitoring, or even internal reuse strategies. These aren't just environmentally sound, they really make financial sense. So to get started, businesses can get started with water conservation by following these steps. So the first step is really to have corporate commitment. It all starts with, your company leadership and your culture. Then designating a water efficiency coordinator might be very helpful. This ensures that someone is responsible for monitoring the water usage and identifying inefficiencies in their different processes and systems. Businesses should develop a mission and an action plan. This keeps conservation efforts aligned with daily operations. But policy alone isn't really enough. It's also important to educate and involve our employees. Reporting leaks, shutting off unused water, and sharing ideas all help create a culture of conservation. And then finally, engaging your vendors and your contractors. Let them know that water efficiency is important to your company and that it's a priority. When it comes to cooling systems, laundry, if it's a case, landscaping, or chemical services. These steps may help lay the groundwork for real water conservation change. Now I'm going to deep dive into some key strategies of water conservation, and we'll cover some practical solutions. For each key strategy, I'll walk you through what it is, how it works, and some real-world examples if applicable. So these are the 5 key strategies that industries can implement to conserve water. So we'll start with talking about water audits and monitoring, which help identify where and how much water is used and or being wasted. Then we'll move on to equipment upgrades and process optimization. And this includes switching to more efficient systems. Third, we'll explore water reuse and recycling, especially in systems where a closed loop reuse is possible. Next is smart water management systems, where the use of sensors, analytics, and automation to take water tracking to the next level. And finally, I'll talk about alternative water sources, like rainwater harvesting and treated wastewater reuse. For each of these, like I said, I'm going to explain what they are, how to measure the impact, and share some real world case studies. So now the first one, conducting water energy audits. So this is really the foundation of any water conservation plan. So before we can reduce water use, we first need to understand where this water is going. So that means identifying which systems, if it's a cooling tower or a boiler, that are using the most amount of water and how much are they using. So facilities can use different tools to track these. One is the ultrasonic flow meter, another one is pressure sensors, and with this, using data loggers to gather real-time data. This helps reveal things like water spikes, pressure drops, or idle time flow that could indicate that there might be a leak in the system in the process. The EPA, they estimate that facilities lose up to 30% of their water due to undetected leaks. So just catching those can lead to major savings. Once the audit is done, you can establish a baseline of how much water is being used, and you can start tracking improvements over time. So that's how you turn a conversation from just guessing the water that's being wasted to something that you can actually measure. Now, this is a process breakdown of how the water audit works. So the first step in a water audit process is mapping the water flow through the facility. This means identifying the different intake points. Where is water going in? How is it being used? Where is it being used? And how is it exiting? Then step two is installing or reviewing meters and sensors. So these might be, like I said, the ultrasonic flow meter or some pressure loggers, anything that helps measure what is happening in real time. And then step three is collecting a baseline data. With this equipment, you can collect the data. Ideally, you want to log usage over 1 to 2 weeks across the different systems. And step four is analyzing the flow patterns. So you might be looking at anomalies like the different water spikes, idle time use, or sudden drops in pressure that could signal a leak. Step five is quantifying the opportunity. So if we know that we're using this amount of gallons of water a day, we can calculate how much that is into a dollar amount, how much we're losing a year of water and how much is it costing us the amount of water that we're losing. And final step is prioritizing the fixes and tracking the changes. So the audit doesn't really stop with the report. It ends with an action plan and measured improvements. So after mapping out where the water is being used throughout the facility, we can use specific tools to gather the detail and reliable data. So like I said, for example, ultrasonic flow meter. These help us detect variations in flow rates, which often reveal inefficiencies, system balances, or leaks. Then another equipment is a pressure transducer. This helps us track changes in real time, sudden drops in pressure, or spikes that can maybe hide some issues like valve failures or line restrictions. Another one is the thermal imaging cameras. So this allows to help hidden leaks, right? Especially in like walls or floors or underground piping, because it identifies cooler, moist areas. So by using this equipment, we might be able to collect data. And with this, we can calculate key metrics. So some of this, for example, gallons per unit of output. We can calculate if it's currently, I don't know, some 12 gallons per item, we might target a 20% reduction. For leak loss rate, if it's a leak of 500 gallons a day, you might want to create a goal of achieve zero visible leaks. And then real-time usage spikes. So during idle times, we can signal flow issues that should be corrected. So these tools don't just support the audit, they really enable meaningful tracking. Because the more precise the data, the more clearly we can measure, benchmark, and reduce the water use over time. So here's an example. In this case study, it comes from Metaldyne Forging Plant in Royal Oak, Michigan. So this facility was spending $500,000 a year on water and sewer costs. So that's a lot of money. Through a comprehensive audit that they did, they realized that a large portion of this cost was due to water loss from their cooling towers blowdown lines. So what did they do? First, they installed water meters specifically on those lines to track unaccounted losses. Water that was literally disappearing without being measured. With that data, they successfully applied for sewer charge exemption, leading to savings of $116,000 per year. But they didn't stop there. They also evaluated a switch to a groundwater system to reduce reliance on municipal water. So that change could save them an additional $272,000 per year. This is a good example of how audits and accurate tracking can uncover hidden costs and how strategic actions, even small ones, can lead to major financial environmental impacts. Now, the next strategy is equipment upgrades and process optimization. This one is straightforward, I would say. Just replacing outdated equipment that is often inefficient. For example, you can switch low flow models or outing automated shut-off valves on your sinks or spray systems, and this will significantly reduce water waste. Beyond just equipment, we also can look at how the process itself uses water. So many industries still rely on water-intensive systems that could be replaced with dry process alternatives or air-cooled equipment. These are often more sustainable and cost-effective in the long run. And even if you cannot replace a system entirely, you can optimize how it's used. For example, cleaning place systems in food processing or counter current rinsing in manufacturing can drastically reduce water use by reusing rinse water in early stages. So we're not just talking about equipment here. We're also talking about making smart adjustments to different systems so the equipment is used in a better way and water is conserved. Now, let's dive a little deeper into how these high efficiency equipment and fixtures can help us cut water use. Now, we'll start with low flow toilets and water saving faucets. So traditional toilets use over 3 gallons per flush, but modern low flow models can use half of that, 1.5 gallons per flush. That is huge savings, especially when you scale that across a very large facility. Excuse me. Water saving faucets and aerators can also reduce flow by up to 50% without sacrificing performance. Then high pressure, low volume spray nozzles. These are common in food processing or industrial cleaning. They are designed to maintain strong cleaning power while using less water. So you get the same result, but more efficiently. Spring-loaded shut-off nozzles are another simple but effective tool. Think of a hose left running on a factory floor. These nozzles automatically shut the flow off when they're not in use, therefore preventing water waste. Another best practice here is regularly inspecting and replacing clog spray heads. So clogs reduce efficiency and force systems to run longer or higher pressure. So routine maintenance in these keeps the systems running efficiently. And then finally, replacing all equipment with modern water-efficient models can save thousands of gallons annually. Whether it's in plumbing, cooling systems, or irrigation, older systems are often full of hidden losses of water. So an upgrade is not just good for conservation, but also good for overall performance. Now let's take a look at an actual impact of equipment upgrades using real data. So in many facilities, hoses are often left running, which is a huge waste in water use. By switching these to trigger operator spray nozzles, the flow drops from 5 gallons per minute to just 2. That itself is a 60% reduction. In the middle bars, you can see a solenoid valve was added to a rinse station so water only flowed when parts were present. That saved over 100 gallons per year. And finally, clean in place systems saw a 35% reduction in water use simply by installing automated shut-off and flow restrictions with no loss in performance. These upgrades aren't really that expensive or complicated, but they deliver big savings. That's the beauty of equipment optimization. It's often low cost and really good and high in return. So here's a real case study, Berkeley Springs in West Virginia. So this case study, it highlights how even a small leak or an inefficiency can add up when it's happening continuously in an industrial setting. So at Berkeley Springs in West Virginia, a distilled water tank was discharging 16 ounces of water every 10 seconds into the sewer during the bottling process. So by running some basic calculations, factoring in the number of operating hours per year and the flow rate, they discovered this small loss added up to over 105,000 gallons of water per year. So that's just not water being wasted, it's also money lost on sewer charges. So by identifying this specific issue through a process audit, they were able to redesign the operation and prevent unnecessary discharge. So for facilities in manufacturing, food processing, or beverage bottling, optimizing water use like this can lead to significant savings without compromising production. Now, the next key strategy is water reuse and recycling. In many industries, large amounts of water are discharged after single use, even though that water is still usable for non-critical applications. For example, gray water from rinses or wash cycles can be reused for tasks like landscaping, cooling towers, or floor washing. We can take it even further by implementing closed-loop systems which capture and treat water used in production and loop it right back into the system. This not only reduces water consumption, but it also limits discharge, which can lower sewer costs and environmental impact. And for facilities that produce larger volumes of wastewater, on-site treatment systems are a great option. Treated water can be reused internally, and in many cases, this qualifies businesses for sustainability incentives or regulatory benefits. So how can industries close the loop on water use? Building on the idea of water reuse and recycling, in this slide, we can see the big picture. So this is how industries can close that loop. Instead of using water once and just sending it down the drain, facilities can actually treat the water and reuse it, either in the same process or in non-critical areas like cooling towers or floor washing. This creates a loop. Use, treat, and reuse. Now, why is this important? Why does this matter? So first, this cuts freshwater intake by 30 to 50%, reducing pressure on local wells and municipal supplies. This is huge during droughts or in areas with water scarcity. Second, it also provides a real cost advantage. So you're saving on both water and sewer bills, which can be major expenses for industrial facilities. And third, it supports your sustainability goals. So this kind of closed loop systems can help businesses earn LED points, which is a globally recognized green building certification program developed by the US Green Building Council. And it meets ISO 14001 standards, or you can even qualify for green incentives. So the big takeaway here is water reuse isn't just good for the planet. It's also a strategic business decision. Excuse me. So now that we have seen how closing the loop works conceptually, let's talk about what that actually looks like in practice. Specifically, where we can reuse the water inside facilities. A lot of industrial facilities, they have processes where they generate water that's still perfectly usable. So instead of sending these straight to the drain, we can really identify where these discharge points are and evaluate whether that water can be reused somewhere else in the facility. So for example, final rinses from like tank cleaning, peg washers, or fermenters can often be recovered and reused. Water from bottle and can soaking can be filtered and repurposed. Things like cooler, flush water, filter backwash, and pasteurized water can be redirected to non-critical tanks, tasks like floor washing or irrigation. Even rinse water from boiler makeup or refrigeration defrost cycles can be captured and reused in other areas. Excuse me. The key here is identifying where water is being discharged and whether it really needs to be discharged. So often making minimal treatment or redirection, we can reuse that water and make a big dent in overall water consumption. And in doing so, we not only save water and cost, but we improve reliability, water quality, infrastructure resilience, and more important, and other things like it can be seen on this graphic on the right. Now, let's talk about how how water reuse loop actually looks like in practice. So the first step of a water reuse loop is identifying where the water is being used for non-critical operations like rinsing, cooling, or floor washing. Then instead of draining this water that's being used, we can collect it, we can capture it, so it can be reused instead of being wasted. Then we treat that water, right? So the water is filtered, settled, or biologically treated, depending on the quality need for the reuse. Excuse me. And then we're stored it. So we can hold it on a tank or a buffer system until it is needed. And then finally, we'll reuse that water and feed it back into the process, whether that's for a pre-rinse irrigation or for cooling towers. So this loop dramatically reduces how much new water a facility needs to bring in. It's cutting environmental impact, but it also saving money. Now here's a case study, a real case study, where they implemented a closed loop reuse system. In Carlsberg Brewery in Denmark, they were facing high water demands in their brewing process. So they installed an on-site treatment facility capable of treating around 2,000 cubic meters of water per day. With this system, they were able to purify around 90% of their processed water to drinking water standards. That treated water was then reused in cleaning and rinsing steps within their brewing operations, cutting down their need for fresh water intake. As a result, they cut their water consumption in half, from 2.8 to just 1.4 liters per liter of beer produced in their facility. And they saved over 560 million liters of water annually. So this case highlights how integrating water treatment and reuse isn't just feasible, but it's also impactful, both environmentally and financially. So after seeing what is possible with water reuse systems, let's make a shift into our next strategy, smart water management systems. So this is where technology really changes the game. Today, facilities can track water use in real time using Internet of Things enabled meters and flow sensors. Instead of waiting for a monthly water bill, you can now catch your leaks or usage spikes immediately. Many of these systems also include automated leak detection and shut-off capabilities. So that means if a valve is left open or a pipe bursts, for example, the system can shut it down automatically, preventing thousands of gallons of water being wasted. Excuse me. And going even further, predictive analytics helps facilities forecast potential inefficiencies before they even happen. So this allows maintenance maintenance teams to act early and optimize the performance, making water management not just reactive, but also proactive and strategic. So now that I have introduced the concept of what smart water management is, let's take a look at some real life examples of systems that can help make it possible. So on the first image on the left, we have a real-time water monitoring system. So these attach to existing water meters and continuously track water usage. So instead of relying on your monthly bill, this gives you data in the moment. So you can catch inefficiencies, leaks, or abnormal usage as soon as it happens. Then in the center image, we see a water detection sensor. So these can be placed near tanks, pipes, or leak-prone areas. So if water is detected by the sensor where it shouldn't be, the system sends an alert immediately where and then alert, whoever is in charge of this area or the system. And this is helpful in maybe basements or mechanical rooms. And then finally, the image on the right is a smart shut-off valve. So this device can automatically stop the flow of water if a leak is detected. This is great for preventing water damage or costly downtime, especially on unoccupied spaces or overnight operations. So together, these three tools, monitoring, detecting, and shutting off, form the backbone of a smart water system that helps facilities respond fast and minimize their water waste. So what do smart water systems actually save? So far, I've talked about what smart water systems do. Now I'm going to talk about how much they actually save. Starting with real-time monitoring. So just having the ability to track water use in real time can lead to a 10 to a 15% reduction in water consumption. So that is because you can monitor immediately and spot where water is being used unnecessarily, like during idle hours or from a leak, for example. Then we have leak detection sensors, like the one I showed in the middle. These can prevent over 10,000 gallons of water loss per year just by identifying the issues early. In some facilities, that can be even higher. Then smart shut-off valves help prevent costly damage. If a pipe bursts when no one is around to see it, it could cost $5,000 to $50,000 in damage costs. These valves automatically cut off flow when something goes wrong. So that is really helpful. And finally, predictive analytics help reduce inspection efforts by 40%. So instead of inspecting everything manually, you focus only where the data shows there's risk. It saves time, labor, and water. So these systems aren't just smart, they're high impact, measurable, and cost effective as well. So to bring this concept to life, let's take a look at a real case study. This case study involves a hospital that experienced recurring water damage, over $1.6 million in past repair costs. So the issue stemmed from pressure vacuum breaker failures, especially during cold weather. So to prevent these from happening, they installed over 40 wireless leak detectors, like the ones shown in the image in the middle, and automated shut-off valves across the facility. And now, when a leak is detected, the system instantly sends an alert and shut off the water. So no manual intervention needed. This simple change is projected to save them over $1 million in avoided damage going forward. This is a perfect example of how smart systems not only conserve water, but also protect buildings and budgets. Now, our final strategy, alternative water sources. This is one of the most overlooked opportunities in the industry. Rainwater, with the right setup, like cisterns and filtrations, help harvest rainwater for things like irrigation, no potable cleaning, or cooling tower makeup water. Another opportunity here is reclaiming treated wastewater. So if water from a process is treated to the right standard, either on-site or by a local utility, it can be reused in operations that don't need potable water. But before implementing either of these, it is important to check local regulations. Some states encourage these practices with incentives, while others may have stricter rules to implement these. So when it is allowed, using alternative water sources can reduce reliance on fresh water, cut costs, and increase your facility's resilience, especially during a drought or water restrictions. Now, let's take a closer look at one of the most practical forms of alternative water sourcing, and this is wastewater recycling. Now, the EPA, Environmental Protection Agency, estimates that each person generates between 50 and 70 pounds of wastewater daily. That adds up fast, especially in industrial settings when we're dealing with bigger facilities. This recycled water, often gray water, comes from sinks, showers, and laundry. It doesn't require advanced treatment and can be reused for non-potable needs like cooling, landscaping, or flushing. Now, to manage and measure recycled water, many facilities install flow meters. Flow meters can help track volumes and show the true impact of reuse programs. By repurposing this water, companies can reduce their freshwater intake, lower the bills, and make quick progress on sustainability. So here are some regional examples. In Fairfax County, Virginia, treated wastewater is reused for non-potable purposes like irrigating parks, supplying cooling systems, and washing vehicles. These not only eases the demand of drinking water supplies, but it also helps the county meet water quality goals for Chesapeake Bay by reducing nutrient runoff. Then in Montgomery County, Maryland, the local building code requires green roofs or rainwater harvesting systems in many new developments. It is a great example of how infrastructure policy can drive conservation. And in Pennsylvania, gray water reuse is permitted for agricultural irrigation, including edible crops. This helps farmers cut costs and conserve clean water. So these aren't just theoretical solutions, they're already being implemented close to home. Now, as the saying goes, you can't manage what you don't measure. Before launching any major water conservation initiatives, you need to know where you stand. So here's some metrics to track. How do we know that our water conservation efforts are working? This is where the metrics come in. So some metrics to track: gallons per flush. This helps us see the impact of upgrading toilets or urinals. Then you have gallons per minute. Measuring flow rates in faucets and shower heads tells how much water is used per minute. Then there's total water saved, which we calculate by comparing the usage month to month or year over year. Cost savings are another key metric. Local water rates help us translate gallons into dollars. And finally, we can estimate carbon footprint reduction, since less hot water use means less energy needed to heat it. Tracking these helps the story of both environmental impact and cost savings. So now that we know what to measure, let's talk about how to measure it. The most common tool is a water meter, which tracks total water usage and gives a baseline. Then utility bills are another simple way to benchmark usage month to month or seasonally. If you see a spike, it might mean a leak or an operational change. For more detailed insight, like mentioned before, we can use ultrasonic flow meters, which can help detect changes in flow rates, and these are great for spotting inefficiencies. Pressure transducers help us catch pressure drops that might indicate issues like clog lines or equipment problems. We also use thermal imaging cameras, will help us spot hidden leaks in walls or underground pipes. These can detect temperature differences caused by escaping water. And finally, Internet of Things sensors. These enable real-time monitoring and alerts, helping us act quickly if something is off. These tools they work best when you use them together. The more data we have, the more precisely we can track savings and make adjustments. Now, here's an example of leak rate. Leaks are one of the most common forms of hidden water loss, often going unnoticed, but adding up to thousands of gallons wasted every month. So to estimate a leak rate, we use this formula. Leak rate is equal to total measured flow minus expected flow. So let's walk through an example. So suppose our flow meter shows 120 gallons per minute. But based on our system's normal operations, we expect only 100 gallons per minute. That is a difference of 20 gallons per minute. That may not seem like much, but over time, that adds up significantly. And if it's hot water, you're also wasting energy. So by identifying that invisible water loss, we make water conservation not only a sustainability effort, but a cost-saving one too. Now let's look at a concrete example of how we estimate savings from upgrading fixtures, specifically faucets. So for this, we use a formula. Water save is equal to old flow rate minus new flow rate times the usage frequency times the number of fixtures. So for example, if we are replacing 50 fixtures and the old models use 2.5 gallons per minute, and we're switching to 1.5 gallons per minute low flow models, and if we plug in the numbers, and also if each one is used for about 10 minutes a day, an estimate, we plug those numbers in, we multiply those across a full year, we're looking at about 182,500 gallons of water being saved. So now if you want to translate that into dollars, just multiply that by your local water rate. That could be a few hundred or even thousands of dollars per year in savings. So this is a great reminder of how even small upgrades like changing your faucets to low flow ones can lead to meaningful savings over time. So far, I have covered the major strategies to conserve water, audits. These are audits, equipment upgrades, reuse systems, smart technologies, and alternative sources. But water conservation doesn't really stop there. In the next few slides, I'm going to briefly talk about some other best practices that can support water conservation strategies. These may seem simple, but when adopted consistently across a facility, they can have a big impact. So outdoor water use is often overlooked, but it can be a big opportunity for savings, especially in businesses with large landscaped areas. So one great strategy is xeriscaping. This means choosing drought-resistant plants that can thrive with little to no irrigation at all. These plants work well for industrial parks, campuses, and public spaces that want to stay green without using a lot of water. Another best practice is installing rainwater harvesting system, like I already said before. This allows the collection and reuse of rainwater for irrigation, cleaning or cooling uses, which cuts down on municipal water demand. And finally, mulching. It might seem simple, but it helps retain soil moisture, suppress weeds, and prevent evaporation. Plus, it also improves soil health over time. But just remember that before installing rainwater system, you need to check with your local regulations to ensure compliance. These practices are low tech, low maintenance, and can make a big difference when it comes to reducing water waste outdoors. Now, let's talk about some process tweaks that can go a long way. These are low cost changes that don't require big equipment upgrades, but can still save a big amount of water. So first, let's consider fogging nozzles. Instead of continuous sprays for cooling, these nozzles use a fine mist to get to the same cooling effect, with much more or less water being used. Another tip is to adjust water flow overflows in recirculating systems. In a lot of facilities, water is added even when it's not needed. So adding float valves or better controls can prevent overflows and unnecessary waste. You can also save water by closing filling lines during operations to avoid overflow when tanks are in use. It's a simple operational change that many teams often overlook. And finally, using surge tanks. Instead of letting excess water flow down the drain, you can store it and reuse it, whether it's for rinse water or overflow from another part of the process. Now let's look at simple ways to save water outdoor. These are useful for facilities with large paved areas or frequent outdoor maintenance. So first, instead of hosing down driveways or sidewalks, maybe sweep them or use a leaf blower. This can help reduce unnecessary water use. It's really easy to switch with zero cost. Second, always use a hose with an automatic shut-off nozzle. This way, water isn't running with while the hose is just being repositioned or moved to another place. And finally, ornamental fountains or outdoor water features should only be used if they recycle their their water. And during droughts, it's best to shut them off completely. If they do recycle water, clearly label it so the public knows it's a sustainable feature. So these kind of outdoor adjustments are easy to implement, but can significantly reduce your facility's overall water footprint. So we have now covered strategies and best practices for industrial water conservation. Implementing them effectively often requires access to the right tools and the right guidance. So in this next section, I'm going to focus on some key tools and resources that are available, especially from the EPA, industry alliances, and state programs that can help your facility evaluate water use, identify water saving opportunities, and track improvements over time. The EPA provides a wide range of tools to help businesses and organizations improve their water efficiency. So first you have the Water Sense program. This is a nationally recognized labeling system for water efficient products for homes and for services. It ensures that performance isn't sacrificed while helping reduce water consumption. Then we have the Water Budget tool. This is particularly useful for facilities with landscaping needs. It estimates the amount of water a landscape should require based on local climate and site characteristics in helping prevent overwatering. Next is the WaterSense Work BMPs, or Best Management Practices. These offer practical recommendations for improving water efficiency across commercial and institutional facilities. From restrooms to cooling towers, this guide outlines how to implement proven conservation strategies. Then we have the Simple Water Assessment Checklist for commercial and institutional facilities. It helps organizations walk through their current water use and identify where savings can be made. It's easy to use and provides a structured way to stop water inefficiencies. Then Water Conservation Plan Guidelines. These give utilities and large users a roadmap to build a long-term strategy. It includes templates and frameworks to guide water-saving policy and infrastructure planning. And last but not least, we have the Energy Star Portfolio Manager. This tracks both water and energy, and it's helpful specifically for facilities that manage multiple locations, since it allows benchmarking, performance tracking, and data-driven decision-making over time. All of these resources are free, easy to access, and widely used across industries to support more sustainable water use. So now to wrap up, implementing water conservation strategies is not only the right thing to do to the environment, but it also makes good business sense. You can save a lot of money. By adopting these best practices that we have discussed today and following some of the key strategies, organizations can reduce wastewater, lower operating costs, and boost their efficiency. Whether you're switching out fixtures, automating systems, or recycling water, even small actions can make a big impact. So these changes not only save water, they also help companies meet regulatory requirements and enhance their sustainability image, something that nowadays it's becoming more and more important to customers, stakeholders, and in some cases, employees. Remember that the key to long-term success is measuring and tracking your progress. With the right data, you can continue improving over time and demonstrate real results. So if you're interested in going a step further, whether it's a water conservation opportunity, an energy assessment, or another type of industrial efficiency project, the WVU 2 team is here to help you. You can reach out directly to Dr. Ashish Nimbarte or Dr. Christopher Moore, whose contact information is shown on this slide. They manage our pollution prevention team, and they work closely with small to mid-sized businesses across West Virginia. We provide on-site assessments, training workshops, and technical support completely free of charge, thanks to our funding support. So whether you're trying to cut down your water use, reduce energy costs, or improve compliance, don't hesitate to get in touch. We would love to work with you to explore next steps for your facility. And thank you so much.